Hi students, again I came back with one more video based on analysis of variance, shortly written as ANOVA. So here, what is meant by ANOVA? ANOVA means analysis of variance, and it is defined as separation of variance ascribable to one group of causes from the other group of causes. Whereas here there are two types of causes. One is of assignable causes and another one is chance causes. Assignable causes are the causes which are under the control of human hand, and chance causes are the causes which are not in the control of human hand. That means you don't know where the chance causes have been occurred. Okay. Now we are going to move on towards the analysis of variance types, where in analysis of variance there are two types. First one is ANOVA one-way classification and the second one is ANOVA two-way classification. In the name itself it is of one way and two way. One way means only one factor we are going to explain, whereas in two-way classification you may have two factors. Okay, and for example in one-way classification we want to explain about the treatments. For example, uh, here this is the procedure for problem based on one-way classification. As of now, we already know about the null hypothesis H naught, where null hypothesis H naught explains you about only there is a significant difference between two variables. For example, similarly here you are going to explain that there is no significant difference between the variables. Okay, and calculate the grand total G. G is the grand total where we are going to get adding the totals completely. Calculate the correction factor. Correction factor formula is G square by capital N. Okay, where N is nothing but total number of observations. And the fourth step is calculating the raw sum of squares, where RSS is equals to summation I summation j xij square, where each and every term will be squared and added. Here, calculating the total sum of squares, where TSS is equals to RSS minus correction factor. Calculate the treatment sum of squares, where SST is equals to summation I total square by its NI minus correction factor. Calculate the error sum of squares, where sum of squares due to error will be denoted by SSE, which is the TSS minus SST. And we are going to form a ANOVA table and we are going to draw the conclusions. Now, we will be seeing one problem based on this. Okay, see. A test was given to 5 students taken at random from the 5th class of 3 schools of a town. You can write here the class at anything, okay? And colleges also you can write. Carry out ANOVA and state your conclusions about the performances. See, here we are going to discuss about only there is no significant difference between the performance of students in different schools. See, the performance of the students in different schools, we are going to treat it only one factor. That's why this is of ANOVA one-way classification problem. The first step of your problem is to set the null hypothesis H naught, where what we are going to discuss, there is no significant difference between the performance of students in different schools. Whereas, what about the alternative hypothesis? This reverse we are going to write. There is a significant difference between the performances of the schools in different schools. Okay. Now, we are going to do the calculations for this. What we are going to find out, ma? In your first page, what we are going to do? Set up the null hypothesis H naught and we are going to discuss about the grand total G. How we are going to get the grand total G? Here. By adding all these values of first school, second school and third school, you are going to get the 35, 25 and 30, which is nothing but going to get the grand total G, as by adding all these totals you will get the grand total G. G is nothing but 90. Okay. Now we are going to find out the value of n. How we are going to find out the value of n? Here, in each treatment, that means how many schools you are having? 3 schools, that is 3, where k is nothing but the number of treatments. Here n1 is equal to 5, n2 is equal to 5 and n3 is equal to 5. Maybe there will be the unequal number of classes also. That means n1 will be different, n2 will be different and n3 will be different. How you are going to find out the value of n? N is nothing but n1 plus n2 plus n3. Whatever the value of n1, n2, n3 are there, you are going to add to get the value of capital N. So capital N is equals to, there the school values are nearly each value is having 5. That's why you are going to get n as 15. Now you are going to find out the next step, that is raw sum of squares. Okay. Where raw sum of squares means what? Each value will be squared and added. See in your question, what is you are having, ma? 9, 7, 6, 5, 8. Everything will be squared and added. That means 9 square plus 7 square plus 6 square plus 5 square plus 8 square still up to 7 square plus 6 square. We are going to get the raw sum of squares. Then what is the value you got? 568. Now correction factor you are going to find out. What is the correction factor formula? G square by capital N. That is 90 square by 15. You got 540. Now total sum of squares. What is the formula for total sum of squares? RSS minus correction factor. That is raw sum of squares minus correction factor. Now sum of squares due to treatments you have to find out. That is sum of squares due to treatments will be shortly written as SST. SST is equals to formula Ti square dot Ti dot square by Ni minus correction factor. So you are going to find out here the values of n1, n2 and n3 are same. That's why we are writing 5, 5, 5. If the values of n1, n2, n3 are different, we are going to write the total by its value. How many number of observations are there? Okay, ma? Only that is the difference between the equal and unequal numbers. Now here you got the sum of squares due to treatments. Now we are going to find out the sum of squares due to error. Formula is SSC is equals to TSS minus SST. Total sum of squares minus sum of squares due to treatments. You got SSC as 18. Okay. Now ANOVA table. Every ANOVA table will be having only these columns. The first one is sources of variation, which will be shortly written as SV. And the second one is degrees of freedom, which is shortly written as D dot F. Sum of squares, S dot S. Mean sum of squares and F ratio. Okay. So in ANOVA one-way classification, you will be having only treatments. For that treatments, you are going to have error. What is meant by error, which is also called as residuals? What is meant by residuals? Where the values which you are going to get by chance causes, we are going to write over here. That is error. Error, degrees of freedom and total. These are the sources of variation for you. Okay. And the degrees of freedom, where under your degrees of freedom, you will be having for treatments, how many treatments? 3 treatments are there. That means 3 schools. You are going to reduce one value for every degrees of freedom. So 3 minus 1 is equals to 2. Here the formula for error degrees of freedom is n minus k. N is nothing but 15. 15 minus k is 15 minus 3 is 12. And total is nothing but n minus 1. N minus 1 degrees of freedom is 15 minus 1, which is you are going to get 14. Sum of squares. Treatment sum of squares, error sum of squares and total sum of squares. What you got in the previous thing, we are going to write over here. By adding these two, you will get total sum of squares. What is the next column? Mean sum of squares. Actually, what is meant by mean? Summation x by n. That means here mean sum of squares we are going to find out. That means the mean sum of squares due to treatments is equals to, here sum of squares due to treatments by its degrees of freedom. That is 10 by 2. Here Mean sum of squares due to error is nothing but sum of squares due to error divided by its degrees of freedom, that is 18 by 12. Now we are going to find out the F ratio. F ratio is nothing but F value, where you are going to find out here in ANOVA one-way classification as F1 is equals to the mean sum of squares due to treatments by mean sum of squares due to error, that is 5 by 1.5. Here you got 5 and here you got 1.5, which is equals to 3.33. This is the F calculated value. Now we are going to compare with the F table value. Where you are going to compare F table value? Its respective degrees of freedom, that is 2, 12. See, F at 2, 12. This you are going to get from the F table value, where that is nothing but 3.88. Okay, ma? Now we are going to compare the calculated value with table value. So, F calculated value is less than F table value. See, F calculated value you got 3.33, which is less than 3.88. Therefore, we accept H naught. What is the H naught here? There is no significant difference between the performances of the schools. Okay. So, this is your one-way classification. Thank you.